Hello, my name is Christopher Archer, and this is my final project for Elen440 Mechatronics. The project itself was meant to represent that of a finger, or the articulation thereof, of multi-jointed devices. The project itself was a 3D printed version based off of a Z1 robot arm from Thingiverse, which I will load into the final project file. So I have a few clips that'll be added in later, but again, the project's premise is to be that of the articulation. The index finger has 3 joints outside of the base of the thumb. Obviously it's not rotary, so it doesn't move, but you've got these two. With this particular robot, it also had a pincher. This being the pincher, we'll get to the problems in a moment. So the idea was to be able to essentially do this and then pick up a device kind of similar to what you would use for a picking and sorting device if you were to use one, kind of like we've had over the several different assignments where it's been a rotary base. It's said I need to go here, pick up a device, turn, etc. This device operates similarly. The only issue right now is that there's no control position, so meaning I can't tell it to turn 90 degrees and then pick up and then turn 90 degrees the other way. Get into the problems with that, but that's a future iteration into something that I would like to have to happen. So demonstration wise, I'm going to add the demonstration into this because it makes it easier, but I will also add the other demonstrations that I've done previously. So here we go. The challenges to this were the fact that, one, figuring out something to build, printing it without having to spend too much time in design, and then 3, what ended up being the biggest challenge over the last 48 hours has been motors have burned out. One about self-destructed because the wrist that was meant to lift this finger, the gear, the upper gear that moves the top shaft, shattered. So here we go. Again, there is no, it's an open loop control system with this one, and the reason being is using the gyro and the accelerometer for some form of control is not something that I was able to accomplish due to time, but the code is running, and using the code to rotate the base clockwise, base runs clockwise. Oops, it stopped rotating. Well, I know why. Anyway, counterclockwise, rotates counterclockwise. The cabling is a bit, fun on this one. So it's set at a position of 120, which is 2.1. The pulse is 2.1, should be about 1.5. So we'll go up. That's 100. It's 20. So straight up and down. And then we are going to move up. Stop, move down, and to show that the accelerometer works, we're going to move up, and as it moves down, same thing with the gyro, because the gyro is on the long arm. Go up, move down. Well, that is the majority. Again, I was able to capture some other video of testing the other articulation of the hand and the third moving piece. So this part to move up and down was able to be done. the key takeaway from this was design. Figuring out how to get into LabVIEW, integrate both the accelerometer and the gyroscope using the code that was given for the demonstrations throughout the course. That took almost 12 and a half hours to get them to work. I could get one to work and then the other would not, and they would not operate simultaneously, but now I have learned how to put two devices on an I2C bus together. So that is the biggest learning outcome for me. That, along with figuring out how to get the continuous rotation, because that's a continuous rotation motor, how to get it to stall in a sense so that it actually moves to its particular spot and to move smoothly. The bottom one is a half rotation or partial rotation, so 200 degrees of movement. That one's fairly simple. Just need to change the frequency to it and it'll move a little better than current, but none of these motors are meant to operate a whole lot of weight. So under continuous usage, these types would destroy themselves, and then it would be an issue. But anyway, my name is Christopher Archer. This is my final project for the Elen440. Thank you, Dr. Doyle. It's been fantastic. This is my last course with AMU. Best of luck, and maybe I will see you in the future, potentially. Have a good one.